is Nur Atika binti Abdul Rahman, A20A1692 as first presenter. Introduction. Statistics is a branch of mathematics that deals with analyzing, summarizing, and interpreting a group of data. That's 1.0 data description. 1.1 analysis data. The table above shows the data analysis for age, BMI, children, chart, sex, smoker, and region for 1,338 people that taking a life insurance. From the analysis data, we can see the mean, standard error, median, mode, standard deviation, and so on. The mean for the age variable was 39.207, while the BMI was 30663. Next, the mean of variable children, charge, and sex were 1.095, 13270.422, and 1.505 respectively. Base 1.795 is the mean for the smoker variable, and 2.484 is the mean for region variable. 2.0 sampling data and record categorical data. 2.1 data urbanization for insured age. This is ungrouped data for the age of insured person. There were 350 people taking of life insurance. Following data, this is the age of insured persons. Next is group data for the age of insured person. Step 1 is decide the number of class, which means is K. Hence, by using the formula 2 square root K bigger than N, number of class K is 9. Step 2, determine the class interval of class width. Class width formula is maximum entry minus minimum entry divided by number of class. And the answer is 5.1, round up to 5. Step 3 is set the individual class limit. The minimum data entry is convenience lower limit for the first class into the lower limits of the remaining class. Add the class width of 5 to lower limit to each previous class. The upper limit of the class is 18, which is 1 less than lower limit of the second class. Step 4 is make a tally mark for each data entry in the appropriate class. Step 5, the number of tally remark for a class in the frequency for the class. The table shows insured age frequency distribution table. Relative frequency distribution. The relative frequency is the portion of percentage of the data that falls in the class. To find the relative frequency, class frequency divided by sample size. And this is table of insured age relative frequency distribution. For cumulative frequency distribution, the cumulative frequency of a class in the sum of the frequency for the class and all previous class. The cumulative frequency of the last class equal to sample size. And this is table that show insured age cumulative frequency distribution.
My name is Nurcha Matumat. My number is 823-1765. I will present 3.0 numerical descriptive measure. 3.1 Measure of central tendency. A measure of central tendency is a single value that represents the center of distribution. 3 most commonly used to measure central tendency by mean, median, and mode. In the following section, we will show how the mean, mode, and median are calculated for the group data. First is mean. Mean is the total value of data entries divided by the number of entries. The formula of mean for group data shown below. And the result for mean age is 39.44. And for BMI is 26.58, and for the charges is 14070.22. The second is median. The median is the median number in the sorted ascending and descending. List of number and can be more descriptive of the data set than the average. When the odd number of data entries, the median is the middle value in the order. If there is even a number, the median is the mean of two middle data entries. Below of the data formula for group data. Median for age is 38.50. BMI 30.27, charges 9932.83. The third is mode. The mode is the number that appears most frequently in the set. If there is no entry is repeated the data, set is no mode. If two entries occur with the same greater frequently, each entry is mode and the data set is called bimodal. The formula of the mode for group data shown below. The result mode for the age is 40, BMI 27.69, charges 11015.80. 3.2 Measure of position. A measure of position is a method by which the position that particular data value has within a given data set can be defined. To determine the measure of position, the data must be sorted from lowest to highest. First is quartile. A quartile is one of 3 points that divide a data set into 4 equal groups. In slideshow, we can see formula to find quartile. Quartile 1 for age 26.60, BMI 26.19, charges 5213.12. Quartile 3 for age 52.57, BMI 34.92, charges 1794.204. The next is interquartile range. The difference between the upper and lower quartile is called the interquartile range. The interquartile range is equal to Q3 minus Q1. Before determining the interquartile range, at first we need to know the value of the first quartile and third quartile. First, range for age is 25.97, BMI 8.73, charges 12772892. The last one is frequency measure of variation. Some parameter items to describe the amount of variation between random variables. There are 3 parameters to measure of variation are used to quantify the amount of variation in a set random variable. The parameter is frequency range, variance, and standard deviation. First is range. Range of the data is the difference between the maximum and minimum data introduced from the data. A large range means high variability and small range means low variability in the distribution. The formula used to calculate range is below. Range for age is 46, BMI 63.10, charge 50057.55. The second is simple variance. Variance refers to statistic measure of the spread between numbers in the dataset. Especially, variance measure how far each number in the set from the mean and thus from every other number in the set. Variance of random variable can be defined below. In the slideshow, this is simple variance formula. Simple variance for age is 207.35, BMI 31.84, charges 2368831.22. And the last one is standard deviation. Standard deviation is a statistic that looks at how far from the mean a group of numbers is by using the square root of the variance. Standard deviation is calculated as the square root of variance by figuring out the variance region is data point relative to the mean. The more variable the data set is when the large the standard deviation. The formula used to calculate standard deviation is in the slideshow. Standard deviation for age is 14.39, BMI 5.64, charges 1539.10.
Hi, good evening, Dr. Tan Wai Hong. I am Nur Ansha Balkis binti Zainuddin, my metric number A20A2215. Today, I would like to present 4.0 graphical representations. Graphical representations refer to the use of chart and graph to graphically show and analyze, explain, comprehend numerical data, functions, and other qualitative structure. The type of representations graphic used will depend on the nature of the data, whether it is quantitative or qualitative data. We present our data in histogram, frequency polygon, or give bar chart and pie chart in this report. Histogram is a bar chart that represents the frequency distributions of a data set. The vertical scale measures the frequency of the class, and the horizontal scale is the quantitative and measure the data value either by class midpoint or class boundary. We use class boundary as our horizontal scale. Class boundary is the number that separates classes without forming gaps between them. We need to minus 0.5 in lower limits to get the lower boundary and add 0.5 in upper limit to get the upper boundary. The data on the table is the age of the insured person, and that is the graph of histogram of the age of insured person that we label with class boundaries. From the graph, we can get that the highest frequency of class limit is from 18 to 22 years, and the lowest frequency of class limit is 63 to 67 years. So we can make conclusion that people at age of 18 to 22 years are the most that taking the life insurance. Frequency polygon is a quantitative variable data. A frequency polygon is a line graph that emphasizes the continuous change in frequency. The vertical scale measures the frequency of the class, and the horizontal scale is the midpoint of the data value. To find the midpoint, we need to add lower class limit with upper class limit and divide by 2. The data on the table shows is the BMI of the people that taking life insurance, and there is also the graph of frequency polygon that shows the BMI of people taking life insurance. So from the graph, we can get the highest frequency is 86, at the midpoint 25.955 and 29.955. Bar chart is the distributions of a categorical variable that shows the count for each category next to each other for easy comparisons. The bars are separated to emphasize the fact that each class is a separated category. The data on the table shows how many children that the insured people have, and there is the bar chart of the number of children that labeled with frequency. From the bar chart, we can get the highest frequency is 152 from 0 children, and the lowest frequency is 2 from 5 children. Lastly is pie chart. Pie chart is a curve that is divided into sectors that represent categories. The area of each sector is proportional to the frequency of each category. The data on the table show the number of the insured gender, which is female and male. The frequency of female is 174 and the frequency of male is 176. The formula to calculate the relative frequency is class frequency divided by total frequency. For example, female is 174 divided by 350 is equal to 0.4971. That's all from me. Thank you.
Next point is 5.0, Statistical Analysis Using Software. 5.1, Numerical Descriptive Measure. As we can see, the data show manual and SPSS. The data of mean, median, and mode show the difference between manual and SPSS result. This is because the SPSS cannot read the data accurately. The second is measure of position. As we can see in the slideshow, quarter 1, quarter 3, and the range show different results because the error of system SPSS to analyze data accurately, which if the data class interval is too large. The last one is measure of variation. As we can see in the slideshow, the result SPSS for data simple variant and standard deviation is not same as manual because the SPSS cannot read the data accurately.
Hi and good evening, Dr. Tan. My name is Muhammad Farhan Nazifi bin Azman and my metric number is A20A1518. I will present 5.2, 5.3 and 5.4, which is hypothesis testing, correlation analysis and the confidence interval. For hypothesis testing, firstly, hypothesis testing is a statistical inference method used to determine whether the difference between a sample and the population is caused by a sampling error or essential difference. Significant test is one of the most commonly used method in hypothesis testing, and it also the most basic form of statistical inference. For hypothesis testing, firstly, we use the t-test. The first step we need to do is to state the null and the alternate hypothesis, which is equal or not equal the charge. The next step, we need to identify the level of significance, which is alpha equal 0.05. And lastly, we reject the null hypothesis since 20.875 is greater than 1.703. Secondly, we use ANOVA for the hypothesis testing. For ANOVA, firstly, we need to state the null and the alternate hypothesis. Next, the significance level, which is alpha equals 0.05. And lastly, based on the SPSS output, we reject the null since 4.963 is greater than 1.97. Therefore, there is a significance difference among the treatment. Next, the correlation analysis. Correlation is a statistical technique used to determine the degree to which two variables are related. Correlation analysis is a statistical analysis method that studies the correlation between two or more random variables in the same position. Based on the Pearson correlation analysis by using SPSS, we measure the determine the relationship and the strength between the variables. A relationship occurs when change of one variable tend to go along with by constant change in the other variables. During our study, we measure the correlation between the age and the charge. And lastly, a confidence interval. A confidence interval is a range of values within the population parameter is expected to occur. The 95% confidence interval can be related to the confidence level. Based on our result of SPSS above, the upper boundary and the lower boundary are 1.9654 and 1.7089 respectively. Also, the standard error for this is 0.06523, and to conclude, 95% confident that the parameter is between 1.7089 and 1.9654. That's all from me. Thank you.
My name is Nurhijrah Munawwarah binti Shawal and my metric number is A20A186C. I want to present about 5.5 prediction modeling. In this result, the R values between age and charges are 0.231 while BMI and charges is 0.183. Thus, charges is not associated with both age and BMI. The R value between age and BMI is 0.090, which less than 0.85. Perhaps there is no problem of multicollinearity. The model summary table, the R-square value is 0.104, which means 10.4% of the variation in age can be explained by BMI and charges. The adjusted R-square is 9.9%. The Durbin-Watson statistic of 1.913 is not too far from 2. The p-value from the ANOVA table is less than 0.001, which means that at least one of the two variables, charges and BMI, can be used to model age. For the coefficient table, the general form of multiplied linear regression is y is equal to b0 plus b1x1 plus b2x2, where B0 is the estimate for B0, the intercept, B1 is the estimate for B1, slope of the line, X is the value of the independent variables, Y is the predicted or estimated value of the dependent variable. The equation is H equal to 28.781 plus 0.186 for BMI plus 0.000 for charges. From the equation, B0 is 28.781. When the BMI and charges are 0, the H will go up by 28.781. Thus, for every increase in BMI, H will increase by 0.186, provided the charges level remain unchanged. Similarly, for every unit change in charges, H will go by 0.000, provided the BMI remain unchanged. The p-value for BMI is 0.159, charges is 0.000, which is less than 0.05. Thus, BMI is a significant predictor of age. The 95% CI for BMI are negative 0.073 and 0.445, while for charges are 0.000 and 0.000. For the concluding remarks, we use a variety of numerical descriptive measures to describe the dataset, including measures of central tendency, measurements of position, and measures of variance. We also utilize the SPSS system to characterize our dataset using numerical descriptive measures, and we discovered that the values we produce manually differed from the values generated using the SPSS system. We get the shape of distribution of age and charges is skewed to the right, which is mean greater than median, median greater than mode, while the shape of distribution of BMI is skewed to the left, which is mean less than median, median less than mode. Then, we use histogram, frequency polygon, and OGIF as quantitative data to represent our graphical. We also use bar chart and pie chart as qualitative data to represent our graphical. We utilize a one-sample t-test and ANOVA test to assess our hypothesis. The 5 essential phases, which are state, the null, and alternate hypothesis, significant label, SPSS output, decision rule, and decision were all demonstrated in detail. We may infer that the SPSS system is highly beneficial for extracting information from data. We can also learn something new about this system, which can make work easier by eliminating the need for manual calculation.